Welcome to my project bazaar.com. Let's see the title of our project. Our project title is EGC monitoring system using Android. Let's see the abstract of our project. The electrocardiogram is an important tool that interrupt the wide range of the heart condition. Early warnings and patient awareness are critical in preventing permanent heart damages and saving much of the heart muscles. These critical conditions motivated us to propose an application that shows the promise for the long-term ambulance EGC monitoring. The aim of this paper is to develop the prototype Android EGC application that works with the existing EGC acquisition device. The application will be useful for the relation of the EGC data signals that are sent from the EGC acquisition device via Bluetooth communication, calculate heart rate and the plot in an Android mobile phone, and also send this information to the concerned physical through server. We have tested this application in real time by collecting the EGC from the patient inside stationary as well as the moving condition. In both situations, this application fulfills the requirement of the proposed system. In EGC electrocardiogram, in the heart muscle cell, electric activation takes place by means of the same mechanism as in the nerve cell. That is from the inflow of sodium ions across the cell membrane. The amplitude of the action potential is also similar, being above 100 volts for the both nerve and muscle. We will be using 3 EGC sensor electrodes to measure the EGC signal. A biopotential electrode is a transfer that sends ion distribution on the surface of the tissue and converts the ion current to the electronic current. An electrolyte solution is placed on the side of the electrodes. The Bluetooth module is a short-range communication system intended for the cable replacement between electronic device. Is a low-cost or low-robust. A Bluetooth system consists of the RF transceiver, baseband, a Bluetooth RF receiver baseband protocols or suffering services. First, in the initialization communication with the EGC system, this module is involved with the settings of the communication with the EGC device using the Android Bluetooth API. Identify the mutual recognition between the device and the receiver sensing acknowledgement to the hardware. It consists of the EGC electrocardiogram amplifier, microcontroller and the Bluetooth module. EGC electrocard will capture the electrical signal and send them to the operational amplifier. The output generated by the amplifier is analog form and need to convert it in the digital form. The microcontroller will process the output from the operational amplifier and perform the following tasks: sample unlock values from the EGC and convert them to the digital. Serial port configuration, control sample rate and sending data via the serial port. This Android application that developed in Android operating system. This will act as a graphical user interface of the system. User can easily interact with the system. Data from the EGC sensing hardware can be shown in graphics with a smartphone application. The ECG app frameworks is used to easily to integrate this application with any other Android phones. First, in the EGC signal grapher that contains way to measure and diagnose the abnormal rhythms of the heart. The output of the EGC record is a graph or other software with the voltage representation and y-axis and the time representation and the x-axis. A dedicated ECG machine would usually print out the graph paper having a background pattern of the 1 mm square, usually in a green or red, with the bold deviation of every 5 mm in both horizontal and vertical. Although it is possible to alter the output of the most EGC device, but it is standard to represent each MO on this y-axis as 1 cm each second, 2 km on the x-axis per second of the. We can also use fast paper speeds for the example to resolve the final data of the EGC. One small block of the EGC paper translated to the 40 ms. Let's see the data flow diagram of this project. First one is start module, another one is read dataset module, next one is analyze module, next one generate ECG signal, next one is sentence mesh. The read dataset module that is used to the read dataset from the devices. After reading the dataset will be analyzed through Android system. After analyzing, the EGC signal that generated will be generated. In first initially, this module involved with the setting of communication with the EGC device using the Android Bluetooth API. After that, getting the data from the device, the next module that performs the read and display the output from the EGC system. The smartphone reads the data from the dataset. After analyzing from the data that it displays in the screen, the EGC packet will be decoded and plotted using in the Java language. Analyze the EGC wave. We will analyze the EGC wave by continuing the spikes in each cycle of the EGC wave. Highest spike value is calculated and compare with the threshold value. If it is not between the threshold, then sort is generated. After that generating, two types of alert can be generated: call alert and message alert. A call or message can be sent to the emergency phone number stored in the phone. A countdown will be displayed in case of the stored in the phone. A countdown. After that, sending data to the ECG wave can be periodically sent to the doctor on his system for manual analysis. This EGC wave will send over the internet after a special time or the doctor's request, or even patient can send it. Let's see the demo of this project. This is the starting page of our application. First one is the start measure button. The next one is the real-time EGC signal measure graph, and the next one is real-time frequency domain graph. In the x-axis contains the heart rate value and y-axis contains the date representation. The next one is text view heart rate that indicates the heart rates and convert into the decimal numbers. So after clicking the start measure button, the data will be analyzed and the Fourier signals will be developed. After generating the real-time frequency domain signals, this real-time frequency domain signals converted into the real-time ECC signal measure. After the ECG signal is measured, the data, the heart rate decimal will be displayed in the down of this application. The heart rate value is 36 pm. So if the heart rate value is critical, the message will be automatically sent to the corresponding doctor or the relatives. In this, after clicking the start measure, the receiving of the data from the server is stopped and send the data to the server also stopped. So finally, start measure that's always after the currently the other data values. So the x-axis values that contains the 3.051 point, and y-axis values contain the measured data. So unless we will analyze the EGC wave by continuous spike in the each cycle of the EGC wave. Higher spike value is calculated and compared with threshold values. It is not between the threshold and alert is generated. So after that, smartphone reads output received from the dataset module and displayed it on the screen. The EGC packet will be decoded and plotted using Java. After plotted, if the value is critical, the SMS will be automatically sent to the doctors. So after that, send data to server. So that after getting the heart rate value into the 42 pm, the data is always sent to the doctor server page. If the internet connection is always available to send the data to the server, so the doctor can anytime to submit the data and verify and analyze the heart rate data. If an emergency occurred, the emergency alert will be sent to the doctors and the particular parents. So we propose system which will continuously monitor the ECG of the subject based on the Android OS platform. This system can monitor and diagnose patient heart condition in real time with an EGC sensor and generate alert whenever deviation is found. This system will analyze the EGC wave and generate the proper error message, and also send the EGC signals if necessary to the clinic or doctor system. Thank you.